Okay, let's move on to the second question. So it's all about transition elements and their properties. Obviously, first question is related to definition. So you must provide your answer having two key parts in your answer. So first of all is that transition element produces at least one stable ion and its configuration partially filled. I mean, d orbitals are partially filled. So this is an important part of your definition. Without it, it has no any sense. Next, you also need to explain why transition metals can produce complex ions. So you need to say that there are backend d orbitals that are energetically accessible to make dative bonds with ligands in coordination complex compounds. All right, next part is related to the definition to terminology. So you need to explain what does mean the term degenerate the orbitals. So as you remember, these orbitals are of the same energy. So this is just a normal configuration of any transition element in its standard state, for example, in form of salts. But when you dissolve them in water or add other substances that can behave as ligands, these d orbitals become non-degenerate. So they split by energies depending on the type of complex you have, depending on its shape. So whether it's octahedral or tetrahedral complex or linear, splitting pattern is different. So these orbitals are known as non-degenerate. So they are of different energy while here it's of the same energy. Next question is related to the shaping of these orbitals. So there are five types of orbitals. So we can classify them into two big groups. So first group is orbitals shown between axes. So it's between axes. And second type is within this axis. So these three, the xy or xz or yz are known as orbitals between axes. So when you show their shape, you just show that flower shape orbital between these axes. So it's xy. So we need to just choose that x and y axis and show that orbital like that just between them. And that's the only correct answer for that case. If you have to show orbitals yz, so you need to place them right between these axes. And same for xz. While the second type of orbitals, just to mention them, it's just dx squared minus y squared and dz squared. So it's all about orbitals shown around the same axis. So it's not between, but around or within the axis. Next question is related to chemical properties of complexes, especially this is shown to explain how complex compound is produced. So there are two reactions given and you have to show the equations for each step. So this Tollens reagent is just a complex compound of silver. In other words, we can say that it's diamine silver ion and it's prepared as shown below. So you have to show reaction equations. So everything is actually given here and you can construct your equation from it. So first reactant is shown, the second as well. You have one of the products and you have to deduce the other product. So this is already given according to the description. So in step one, you have all of these substances assigned as reactants or products. How to come up with the rest of them. So you have nitrate ion and sodium left not shown here, so probably it can be combined in sodium nitrate. And here it is, we are showing it like that. And you also have hydrogen left, which is not shown in any of these products. So probably hydrogen in hydroxide group produces water. So you have to just remember that usually water can be made during the reaction, or it can be a reactant as well, even if you're carrying out the reaction in aqueous solutions. So this is also possible, and this is the most probable substance. Uh, Except this, you also need to consider if your reaction equation is balanced. This reaction was not balanced before, so you have to balance it. So balancing is already done, so you need to double the reactants and one of the products, which is sodium nitrate. Second step is also shown, so what do we have? We have one reactant, ammonia, and we have a product produced before as a reactant here. So this information is already given, and you have some information about your product, which is shown here. Um, Again, there is no any other product indicated in the description, so probably we also don't have anything like that. And we need to understand whether the reaction equation is balanced or not. So you also have to include water in the reaction equation, as I told you, because without it, it is impossible to balance your reaction equation. So it's like to memorize that sometimes water could be a reactant as well. And don't forget to balance. Without balancing, your answers will not be accepted. Okay, let's move on to the next part of this question. So this is all about shapes and angles. So you have some information about the structure, and you are asked to show the shape and angles for specific bonds. So look at this case. So in this part, you have to consider what's the central atom in this part of the complex. And central atom is nitrogen atom. You also need to understand what type of other atoms can be around this atom and are there any lone pairs. So in fact, nitrogen is coming from ammonia molecules. So there are three hydrogens and one pair of electrons is used to make a dative bond with silver ion. So you are asked to show these bonds. And from valence shell electron pair repulsion theory, you should remember that in case when you have four bonding pairs and zero lone pairs, that usually results in tetrahedral structure. Sometimes it's square planar, but with certain groups of atoms, like platinum, nickel complexes. But overall, mostly we have tetrahedral shape. And in tetrahedral shape, the bond angle is given and it's specific and it's equal to 109.5 degrees. And you also must show the bond angle here. So there are only nitrogen atoms in the complex. So you have two bonding pairs, zero lone pairs, and this results in linear shape, which is also asked here. Okay, shape is linear for this part, and bond angle is 180. While here is tetrahedral, and you are not asked about the shape of this part. So the shape is asked only for this ion. So it's one ligand, another ligand, and central atom, central ion is silver. Okay, next part is related to redox reactions of transition elements, some of them. So what do we have? Overall reaction in the cell is given. So during that reaction is electricity is produced. So electrons are lost and gained during a spontaneous reaction. So uh, something gets reduced, something gets oxidized, and you have to show them all in these parts of the reactions of positive and negative electrodes. So you have to first look at your equation and assign oxidation numbers of elements, and you'll figure out after this that silver was having oxidation number +1, and after that reaction it turned into 0. Zinc also has changed oxidation number from 0 to +2, so it's simple redox reaction. And you have to understand what is happening with silver. So silver changes its oxidation state from +1 to 0. and its oxidation process. And if you remember, according to oil-rig mnemonic rule, oxidation is, so it's reduction, sorry. So according to that rule, reduction is gain of electrons. So one silver ion needs one electron to turn into silver neutral. But we have to double this because silver is represented as two atoms here. So we have to show two atoms of silver, and two atoms require two electrons to get reduced from silver ions. So we show two electrons and silver two here. Then we have to balance the equation. So we have oxygens in the left-hand side. We don't have any oxygens in the right-hand side. So usually we balance it just adding water in the right-hand side and hydrogens in the left. But you have to pay attention to the conditions given. So you have alkaline electrolyte. So you can't just add hydrogen ions in this half cell. You can only add water and hydroxide ions. In that case, usually hydroxide ions are placed in the right-hand side, water in the left. If you put one hydroxide, oxygen will be balanced, but you cannot balance hydrogens because it's just one hydrogen, and you cannot place H plus ions here. No. So you better double this and put water here. So in that case, you have two oxygens and two hydrogens in both sides of this half equation. Now the reaction equation is balanced. And this reaction takes place as at the positive electrode, which is the cathode. Next, we have to show what happens with zinc. So zinc turns into zinc hydroxide, which is shown here in the right-hand side. Then you also need to understand what is happening with zinc. So zinc gets oxidized, and oxidation is loss of electrons. We show them here. And one zinc atom needs two electrons to convert into zinc 2 plus ions. We show them in the right-hand side. And again, we are balancing using hydroxide ions and water only. So if we place two hydroxide ions in the left-hand side, we don't need any water to place in the right-hand side because everything is already balanced. And that's how we show the reactions at the anode. So this is anode reaction, this is cathode reaction, but still you are not asked to indicate them as cathode and anode. All right, next question is a bit tricky. Most students may fail this question, and that's absolutely fine for Cambridge. So you have some information about new types of complexes and new types of polymers. You probably have never heard about them in terms of your curriculum. And you have some information that about how these polymers are made. So there's some information that they are made by combination of ruthenium and DPS molecules as acting as ligands. And there are also monodentate ligands. Structure of DPS is shown. And you have to show, look at the task itself. Oh. So what should you do? You have to show the structure of coordination polymer using two repeat units. And you have to simplify this part as shown here. So you can use that representation to show that DPS molecules. So according to the definition of the term polymer, you should remember that polymers are huge molecules that has a lot of repeating units. And this is like new type of polymers. So you need to have the same species here. If you are asked to show two repeat units, you are not asked to show the structure of the polymer only. So you better show it here once more time. You are not asked to show the geometry appropriately, so in that case you have to show these ones like directed towards you, these ones from you. So, but we are not asked about them. And some hints are already given. So the structure of the polymer is shown here by the formula. So you have some repeating units containing this number of ligands of DPS and chlorine ligands. So you can assign 4 chlorine ligands after you assign 1 DPS. So DPS is a bidentate ligand. So finally, you have to connect them like that. So it's like a bridge between these complexes. And you have to also understand that these bridges um, are used to connect these complex ions from both sides. So you also need to choose one other bond to show the rest of the polymers. So I think this part would be fine. So I have to show that from this side, you also have some repeating units, but we are not showing them because the question says that we have to use only 2 repeating units. Then you have to do the same from the right-hand side. So the repeating unit contains something like that. And you have to show it in the right-hand side using one more bridge and showing the possible bond that could be made. So that is another repeating unit. As you see, they are repetitive. You see one unit, another same unit. They must be absolutely the same. If you place here one more bridge, that would be incorrect. So be careful here. Don't put another unit. And then assign the rest ligands, which are 4 chlorine ligands. Here they are. And now you see this aligns with the formula given. And the complex ion itself is a negative ion, so I don't know whether you need to show it or not. So that's it. You have 2 points for this question. First, probably is just to show one repeating unit, another just to show 2 repeating units, another mark just to show that they are binded with each other with that one bidentate ligand. So that's it.